Hi, in this video, I'm going to teach you how to using the double angle formula or all the identity formula, the Pythagorean identity, the compound angle formula to prove some identity. Alright, use the basic identity means that the double angle, the compound angle, and the Pythagorean identity, all is the basic identity. So using all the identity to prove others' identity. For example, look at this one. Prove that sine 2 theta and 1 plus cos 2 theta is actually the same as the tangent theta. So our target must correct when we proving identity. First, you look at here. There is a double angle here, right? There's a double angle here. So how come a double angle become a single angle, right? So it must be using the formula for double angle. So we list out the formula in our mind. We know that sine 2 theta, we have sine 2 sine theta, cos theta, right? Double angle. So if you have cos 2 theta, you will have cos square theta minus sine square theta, or it can be 1 minus 2 sine square theta, or it can be 2 cos square theta minus 1, right? It's up to us to decide which one should we use, right? So let's look at this one. We have to prove that the left hand side, this is a simplified form for this, right? So usually we want to proving something, we don't use the simplified form, we use the one that haven't simplified. It means that we are actually trying to simplify this to get this, right? We are proving that if after we simplify this, we were getting this. So the left hand side, which will be your sine 2 theta over with 1 plus cos 2 theta, right? So sine 2 theta, don't need to think so much because there's only one formula. So you have 2 sine theta cos theta, right? And 1 plus cos 2 theta, there are three formula, you know. There are three formula. Which one to choose, right? Based on my experience, I know that if I want tangent, because I know that in my mind, tangent is sine over sine theta over cos theta. This one I know. I know that tangent theta is sine theta over cos theta. Means that at the denominator, I only want cos theta. I only want cos theta. I don't want sine theta. Alright? So I look for the formula that cos theta that contain only cos theta. This one got mixture of cos and sine. This one got sine theta. So this one got cos. So I just choose it. So I just try my luck here. So 1 plus cos 2 theta. I have three formula. I choose cos 2 theta to be 2 cos square theta minus 1. Right? And I also can see that 1 minus 1 is getting 0. Right? Getting 0. So means there is a hope, you know. So you know that 2 sine theta cos theta over with 1 minus 1. 0. Right? So you have 2 cos square theta. It's getting more approach to what you want. So you see that 2 divided by 2 cos theta and cos square theta, the still got remaining 1 cos theta, right? So now you see that sine over cos, you were getting tangent theta, right? So this is what the question wants. So you have already proved that this is true, right? This is your identity, which is equal to the right hand side, right? So, okay, we will do more example for proving how to using all the double angle and the others identity. So let's see the second example. Alright, let's continue with these examples. So means is to prove another identity, alright, which will be let's see what is our identities that we're going to use here. Of course, we will needed double angle formula. Why? You see that double suddenly becomes single, right? So so in your mind, you have to have formula, right? You must have a habit also. There is a habit where every time when you're proving something, you recall back all the formula rather than refer to any formula sheet, right? So it's a attitude to memorize the trigon, a good attitude, the best way to learn trigonometric. Alright, So you have to memorize all the formula and rewrite all the formula every time you're proving. So 2 sine A cos A, and cos 2A, you will have cos square A minus sine square A, 1 minus 2 sine square A, and 2 cos square A minus 1, right? So you see there is a tangent 2A here, but I think I'm not going to use, there is another form for tangent, 2A double angle for tangent, right? So I think I'm not going to use that, because you see that at the final product, your final form, you are getting cosine. There are no tangent here. So I don't consider the tangent 2A here. Alright, so I con this two formula only. So second 2A, you know that second, right? Second 2A, you can rewrite as 1 over second, is actually cos 2A, right? 1 over cos. 1 over cos. And you know that tangent 2A, I want to change everything become sine and cos. It's big sine 2A over cos 2A. Tangent is sine over cos. Theta, 2A. Right? So no, I putting back to here. So the left hand side, right? The left hand side you have second 2A minus with tangent 2A. So now I start to looking at the formula. What is the suitable formula? Second 2A, I have 1 over cos 2A, alright? Okay, I understand that. This will be sine 2A over with cos 2A. So luckily the denominator is of the same term, right? It's the same, right? These two are the same. So 1 minus sine 2A divided by cos 2A. Now this become two term. Combine the fraction become only one term. But how to from here going here? Okay, never mind. We try to look at sine 2A, right? Sine 2A. There is only one formula for sine 2A, right? So just put in the formula, right? Just put it. So 1 minus 2 sine A cos A. 1 minus 2 sine A cos A divided by cos 2A. This is the hardest part, challenge part here is I need to decide what can I do here, right? What can I do here such that I can solve, such that I can getting this thing cos A plus sine A. So I have to decide. So what I can do now will be I try to rewrite cos 2A as cos square minus sine square A, right? Cos square A, 1 minus 2 sine square A, 2 cos square A, cos square A minus sine square A, right? Because I know cos 2A is cos square A minus sine square A. So later I know that 1 minus 2 sine A cos 2A, this one I cannot simplify, I cannot do anything. But I know that the cos square minus sine square A can written as cos A plus with sine A cos A minus with sine B, right? So and the one here, okay, this one I apply the formula, the cos square. This is quite difficult here because the cos square A, you know that this formula, the square of difference here is A square minus B square is the same as A minus B, A plus B, right? It can be A plus B, A minus B, right? So I am going to apply this concept of algebra here. So as you see that cos 2A, cos 2A can rewrite as cos square minus sine square. I just choosing one of the formula, right? I choosing this one because I see there is a cos A plus sine A here, right? There is a mix here. So I choosing cos A and sine square A because after I factorize the cos square A, for example, this is your cos square A, right? Cos square A minus with sine square A. So cos square is A. So means I will getting cos A plus sine A, cos A plus sine A, and cos A minus sine A, right? Because this is your A is cos A, B is sine A. So now I have already factorized the denominator. So, but the problem is the numerator. So doesn't matter, we try. Okay, we try to modify this. As I see, there is a 1 here, right? This 1 is very powerful, right? The 1 here is very powerful. The 1 here, you know that, then you must have acknowledged the Pythagorean identity. The sine square A plus with cos square A equals to 1, right? You know that sine square A plus cos square equals to 1. Other than that, you have 1 plus tangent square. 1 plus tangent square theta equals to secant square theta, or cotangent square theta plus 1 equals to cosecant square theta. But I think these two is not involved in this case here. So I will try to look at this. The 1 you can convert to sine square plus cos square. Alright, I need some space here. So, alright. Okay, look at the 1 here. I'm going to rewrite the 1 as sine square A. Sine square A plus with cos square A minus with 2 sine A cos A. If you not understand, you pause the video again and you see again what is happening here. So the 1 here, I rewrite as sine square plus cos square. The reason is I try to factorize this so that I can cancel out one of the factor here, right? Because you see that finally there is only cos A plus sine A, right? There are no cos A minus sine B. Means something happened here, right? So which we want to cancel out this thing. So okay, let's see. So then I rewrite the cos square A. I rewrite the cos because you see cos minus sine, cos. So I put the cos as the first term, cos square A. Then I write it such that it's a quadratic form. Cos B plus with sine square A, right? Plus with sine square A. So you see, I make the 1 become sine square plus cos square. Because these two add up, you will get 1 also. So divided by cos A plus with sine A cos A minus with sine B. Alright, I need to believe myself, right? So that I can prove this. So I have to try harder. So, and I see that this one, I can relate it to the algebra. It's actually what? A square plus 2AB plus B square. Right? If A plus B square, it will be A square plus 2AB plus B square. But in this case, there is a minus here, right? So I try to think that if this is minus, this is a quadratic. So in quadratic, if you expand A minus B square, you are getting A square minus 2AB plus B square. So now you try to look at it. Actually, your A is cos. I can rewrite this as cos A square. This one as sine A square, right? Cos A minus 2 cos sine, right? You see that cos sine, right? Sorry, this will be cos A also. Sorry, I rewrite this thing. So 2 sine A cos A, right? So it will be cos sine. This one will be B. So means this now is your A square minus 2 AB plus B square. So I can rewrite this thing as cos A minus with sine A square. So divided by cos A plus sine A cos A minus, sorry, is A, right? Cos A minus sine A. So if you see carefully here is this one I rewrite as a quadratic form, means I write in this form. I convert this to this form, right? So then now I can see that cos A minus sine A, here have cos A minus sine A, this power 1, this one power of 2. So if I divide, the index 2 minus 1, so they are same base, right? So I will still have cos A minus sine A on top, right? Power of 2, 2 minus 1 become power of 1, right? Become power of 1. So then after you cancel out this, the denominator you have cos A plus with sine A. Finally, I have already proved this identity is true, right? So you try to look at the way I proving the question. So you have to very good in selecting the formula. So I will given you another two proving in another two type of question that you need to use the double angle formula, the identities, and all the algebra formula that you learn in your secondary school to prove an identity.